Okay, let's start working on the UVs for these and thus fixing this. Essentially, we're going to lay these out in a line. Let's tidy this up real quick. Okay, so after our unique points, put down a wrangle. So you need to figure out how long each of these are. I'm going to call this get length. It's going to be a detail. I'm going to do a float called total length. And it's going to be equal to 0 to start with. Then I'm going to do a loop. So a for loop. It's going to be int. And I'm going to call that prim. And it's going to be equal to 0 because we want to start on primitive 0. And while prim is less than n primitives, so number of primitives coming in on input 0, prim plus plus to increment that. So we're going to make an integer array called points, because we're going to get prim points, and this will just return all of the points, all of the point numbers on a particular primitive. And we're just going to look at our prim that we're currently looping on. Then we need to store. So P0, which is our position of point 0. So input 0, P is our attribute, and we want to get entry 0 from our point array that we just got up here. And then I'm going to do the same thing for point 1. So let's get our length of them. So that's equal to the distance between P0 and P1. And we'll just add that to our total length. Plus equal length there. And then I want to set a point attribute on 0 and I'm just going to set this to length. Set that on point 1. And set that to total length. And set that. And do that again on point 0. Cool. Oops, where have we gone wrong? There we go. Had a full stop instead of a comma there. Okay. So after we've got our length, put down another wrangle. And what we want to do here vector p0, and I'm just going to get the position of point 0, and at p is going to be equal to, and we'll set this, which is making a vector, and in x we want our length, and then we just need to get the position.y minus p0.y to see if it should be, if it's a top point or a bottom point, and then set that to 0. Okay. Oops, did it again. And this should be called move. I'm just going to call it move. Okay. And one thing we want to do before we loop over anything is just quickly store our old positions. So make a vector called original position and make that equal to p, so we can save that for later when we need to move these back. So this should have, if I just deactivate that, lay them all out in a straight line, which will make it nice and easy for us to UV them now. Okay. Now I'm going to put down a divide node. And we don't want convex polygons, we want breccia polygons. And I'm going to set this to 10. And then this one to like just a ridiculously high number. And this will mean we should have nice, perfect lines on 10s all the time. So we can divide these up nicely. And if you want larger UV tiles, or like more stretched UV tiles, whatever this length you want, increase this number or decrease it based on what you want. Promote, and we want to promote our total length, or our length, sorry, to a primitive. Sorry, not a primitive, to a vertex, because we're doing UVs and they'll be on the vertexes. Okay. A null wrangle, and this is going to be set UV. Okay, and in here, it's going to be really straightforward. Switch over to vertexes, v at uv.x equals at length. Then v at uv.y equals at p.y. And that should, just save this real quick, lay out our UVs for us like this. And it should do it for all of them. Cool, but we're not done yet. Okay. Now we need to re-promote our length attribute do a primitive attribute. And then we want to make these into sections. So, oops. UV section, primitives, I at section, and that's equal to round to int at length divided by 10, which is the length of our sections. Okay, now we want a transform UV. So we need to scale these down by our scale we're using for these. So these are 10 units long, so we're dividing by 10. Same with here. And this could be anything, 10, 25. You could also make a slider for it if you wanted to. I'm not going to worry about it. Okay.